Let's get started. I'd like to introduce KYZEN's Regional Manager, Jack Reinke.
Thank you, Cassie, and thank you all for tuning in to this week's KYZEN Tech to Tech presentation. We're going to discuss environmental impact of PCB cleaners today in an attempt to answer the question, to drain or not to drain. Worker safe, environmentally sound cleaning chemistry. We hear this a lot in our industry. What does it really mean? It's a sound platform on which KYZEN products, as well as many others, are promoted. But what does it mean? I hope to answer this question over this brief technical session, to answer the question about modern aqueous chemistries for cleaning electronic assemblies. There's a myriad of choices available when it comes to cleaning technologies. Since the Montreal Protocol in the late 1980s, many products have come out to either alternatives to or direct replacements for traditional cleaning solvents. Even some companies emanated out of this green revolution. But for the purposes of our discussion today, we're going to focus exclusively on aqueous cleaners, and specifically those formulated to run in high production inline spray and air cleaning machines. So let's talk about putting together an aqueous cleaner effective enough to work on defluxing circuit cards. Typically starts with a solvent, a water miscible solvent to dissolve the contaminants, and offering excellent compatibility along the way. Activators are put in to soften those contaminants to help them dissolve in the solvent and also eliminate white residue. From there, buffers are added to maintain a very stable pH that opens up the process window. And then wetting agents are put in to reduce the surface tension for better penetration beneath low standoff components and offer complete water solubility. Finally, inhibitors are added to protect sensitive metals from corrosion or etch. This lowers the cost of ownership and eliminates dull solder joints, keeping those joints nice and shiny. So these ingredients are chosen not only to clean a wide range of fluxes effectively, but to do so in concert, protecting solder joints along the way and providing maximum efficiency in chemical cleaning. So by design, KYZEN aqueous cleaners are compatible with primary and secondary waste treatment. I like to say they're sewerable out of the drum. That's to say they can be treated, neutralized if necessary, and safely discharged to drain. Once the drum is opened and the product pressed into service, we can no longer make that claim, and a permit is required for discharge. So it's the introduction of soils from the cleaning process that really creates the concern and ultimately dictates the fate of the spent solution. So that selection of the cleaning agent has to also consider the soil impact on both the water discharge and waste generation. Environmental concerns over the wastewater typically center around the publicly owned treatment works, POTW, commonly known as the sewer department. And the discharge of wastewater requires a permit under the Clean Water Act. But it also gives rise to the closed loop considerations for water conservation and management, and impacts worker health and safety. The primary factors directly influencing discharge to the local treatment authority. From the cleaning agent side, pH is always of concern, particularly the acid or alkaline extremes in pH. Organics are important, as indicated by the BOD and COD, and the dilution rate of the in-use product is also important because dilution is the only solution to pollution. From the soil load standpoint, lead is always going to be of utmost concern, but other bad actors include corrosion precursors like chlorides, sulfates, bromides, and others, as well as trace elements, including the other heavy metals. Other factors apply, but these are generally the most important and the ones quickly recognized by your EH&S group. Let's take a look at typical effluent limits. This is from a county in Florida typically broken up into organics and heavy metals. You can see that in this case, when a organic level exceeds the established limits, a surcharge is applied. So it isn't that you can't throw it down the drain, you're just subject to a surcharge. This county will levy a surcharge on anything exceeding the maximum. Let's take a look at the inline cleaners. This is an early generation depiction of an early generation inline cleaner with a closed loop rinse. That's a rinse polished through carbon and mixed beds to reuse. They were not configured well to accommodate chemistry, however, since the wash solution would readily drag into the rinse would foam heavily, and then contaminate and quickly foul the mixed beds in the recycling system. This was quickly replaced with the closed loop rinsing with a chemical isolation stage. This chamber was designed to remove most of the cleaning agent from the parts, the baskets, and the conveyor belt before it reaches the rinse section to preserve the integrity of the rinse. That chemical isolation, or pre-rinsate, as it were, is typically discharged to drain. If it cannot go to drain, some applications, some municipalities, some countries absolutely won't let it go to drain. There are other means of managing the discharge, either through reverse osmosis, perhaps. Evaporation is used, a combination of membrane technology and biological treatment, even carbon adsorption, all methods designed to completely remove dissolved organics from this chemiso or pre-rinsate stream before discharge. However, the best, in the end, however, discharge to drain, if possible, is always the easiest and most affordable option. Let's take a look at what the chemical isolation effluent analysis has shown. We've done this several times. This is a 10% mix of a KYZEN chemistry, both loaded with flux and not loaded with flux. The chemical isolation or the pre-rinsate emanating from that. And analysis of these chemiso waters consistently show low to no detectable limits in the organics and negligible amounts of trace metals in the effluent. So, in summary, what is the responsibility then of the chemical supplier versus the end user when it comes to disposal of the aqueous cleaners? Well, as a chemical supplier, we're obligated to provide a globally accepted safety data sheet per OSHA standards. We provide all known information on toxicity, health hazards, safe work practices, any protective equipment that might be required, material reactivity and flammability. All of these things are included in the safety data sheet, as well as the information needed to properly classify a product for disposal into a wastewater stream, all found in the safety data sheet. The end user should seek guidance from either their internal or outside contracted EH&S authorities on local rules for permitting a particular wastewater stream for treatment and discharge. This typically entails a review of the vendor supplied safety data sheet, but also analysis of the combined effluent exiting both the machine and the end of pipe at the facility. National, regional, and local regulations may apply. Some of these are stricter than others, and they will vary rather dramatically from nation to nation. But ultimately, in the end, it's the customer's responsibility to comply with all of the local discharge regulations in the permitting process. So in conclusion, while we can help along the way in every regard, the end user is ultimately responsible for this compliance. So work with that governing body to avoid a fine for unlawful discharge. In a nutshell, get a permit or risk a fine. I'd like to add that KYZEN's contribution to environmental considerations of circuit board cleaners, mostly surrounding water conservation and management, can be found in an IPC cleaning handbook published in 2011 called Guidelines for Cleaning of Printed Boards and Assemblies. A very useful reference for the subject matter at hand. So with that, I'll turn it back over to Cassie for questions or comments.
Thank you, Jack. If you'd like to discuss this topic further, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone schedule a follow-up with you as soon as possible. Again, we thank you all for taking time to join us today, and we hope to see you again real soon. Stay safe, stay healthy, and have a wonderful day.